guys. Somebody left their lunchbox in here, so let's see what's for lunch. Let's see, it's been sitting here all weekend. We've got, ew, it's spilled rice everywhere. Yeah, I'll be just zipping that back up. If this is yours, please come claim it in my classroom. We'll put it right here. All right, so you guys have already learned systems, solving systems by graphing. So today we're going to learn solving systems by substitution. You're going to like this because it's nice. It usually works out pretty well. So write this down in your notes. Your goal is to find out either where the two graphs intersect, at what point, or if they are the same line, or if they are parallel. So like in graphing, you're going to be given two equations of a line. And so in graphing, what we did to solve the system was we said, okay, if this line goes this way and this line goes this way, what is that point in which they cross? Okay, that's the first type of thing. That's the first answer to the problem. In the second type of problem where you had two graphs, you might have found that there was no solution, and the reason why there was no solution is because you found that the two lines were parallel. We know that parallel lines have the same slope, so remember that. And then in the third type, you found that one line was actually the same as the other line. So there's infinitely many solutions. So we're either looking for one solution, no solution, or infinitely many, just like in graphing. When would we use substitution? When it's easy to get one of your equations to be into x equals or y equals. So if you look at your equations and you say, ooh, that would really be easy to get it into x equals or y equals, that's when you would use substitution. And I will show you what I mean. Let's look at our first system. So this is solve the system by substitution. What is a system? A system is two different equations, and we have to figure out which one of these is going to work. So I told you if it is in x equals or y equals, then it's going to be easy to use substitution. Well, conveniently, this one is in y equals. So if I have something in y equals, I basically can take whatever y equals and pop it in for y. It's just like a substitute teacher. I was absent last week because I went on a college visit with Megan. So I was taken out and Mr. Fort was substituted in. I went out, he went in. This y is going to go out because we know y equals this, and we're going to take this and pop it in. There's a lot of substitution used in algebra. So instead of writing 3x plus y, I will write 3x plus this, because this is what y is. I'm going to put it in parentheses because I don't know if I have to multiply anything in this particular equation. You don't, but I'm going to put it in parentheses anyways. Okay, so now I look at my problem here, and I have to combine like terms. Notice I have x's and I have numbers. So I have to get all the x's together and all the numbers together. Well, do I need these parentheses? I technically don't. I can just drop the parentheses because I don't need to multiply anything or anything. And then I'm going to get these two together. Those are like terms. So I get 5x plus 1 equals -9. Now I have to bring this over here. So I'm going to draw a line down here because this is my left side, this is my right side. How do I get a +1 to get on the other side? I have to do the opposite. Okay, so this is a -9 and a -1. That's going to cancel, and I get 5x equals, when your signs are the same, you're going to add the numbers and take the sign. Keep the sign. So now I have 5x equals -10. I need to get x alone. I divide by 5. I get x equals -2. Now I'm going to do substitution again. I need to take that -2. I don't care. I can go to either to this one or this one. It doesn't matter which equation I pop it in for, because whatever equation I pop it in for, whatever the answer is going to work in both of these. That's what I'm trying to do. Okay, so I'm going to just take the first one. I rewrite the equation. Don't be lazy and not write it. And instead of writing x this time, I'm going to substitute y equals 2, parentheses, whatever x is, plus 1. Y equals, parentheses means multiplication, 2 times -2 is -4, plus 1, y equals -3. So my answer is -2, -3. Now, If I take this, what this means, what your answer means is I can plug in -2, -3 there, and it will work. And I can plug -2, -3 there, and it will work. And wherever these lines are, they cross at this point, -2, -3. So let's plug in a -2. I'm just going to do this in my head. If I plug in -2 for x, I'm going to get -6, -2 times positive 2 is -4, plus 1 is -3. So that works there. Now let's plug it in here. -2 for x is -6 plus -3. -6 plus -3 is -9. Notice that they both work. If I graphed them, you would see the point that they crossed would be -2, -3. Make sure you write it in the order of x, y. Don't write your answer in y, x, or it's going to be wrong. You have to make sure you solved for x, that goes first, then solve for y. And you don't always have to solve for x first. Okay, writing this example in your notes. If you look at it and you say, hey, is it in y equals or x equals? Well, yes, I have a y equals right here. So instead of writing y here, I can take whatever y equals and pop it into my other equation and solve. Ready? 5x plus 3, parentheses, 4x minus 6. I just took this and popped it in there, and I did use my parentheses because now I have to distribute my 3. When you have 3 outside parentheses, it has to be distributed to the whole thing. 3 times 4x is 12x. 3 times -6 is -18. Combining like terms, add 18 to both sides. I have different signs. So when I have different signs, I subtract and take the sign of the bigger number. So this is going to work out nicely. I get x equals 1. Take your 1. That's half of my answer. I know half of my answer is 1, if I did it right. Take your 1, go back up here and plug into either one. I'm going to take the first one. Y equals 4x minus 6. Instead of writing x, I'm going to do y equals 4 times 1 minus 6. Y equals 4 minus 6. Y equals -2. So I'm not going to check it right now, but it's always a good habit to check it. If you go back and plug in this point, 1, -2 will actually work in both the equations, and that's where the line will cross. Okay, let's look at this one. Now this is not in, we want it into x equals or y equals. I don't have it into x equals or y equals, but it would be really easy to put this one into x equals. So if I just go like this, I'm rewriting the first equation. I'm going to subtract 2y on both sides, because now I have a nice easy y equals 6 minus 2y. There you go. So, I mean not y equals x equals, sorry. Now I have x equals, it's this one. Make sure whatever you substitute, you go in and put it into the other equation. This isn't going to work if I take this and put it into that one. It won't work. You have to take it and put it into the other equation. I know that my x equals 6 minus 2y, so I'm just going to go 3 times x, which is 6 minus 2y. I'm just writing this. 3 times my substitution minus 4y equals 28. Again, distribute. 18 minus 6y, don't forget to do it to both. Minus 4y equals 28. Okay, I have two negatives. I add them together, keep the sign of the of it and add them. Okay, I'm almost done. I'm going to subtract 18 from both sides. Okay, we always like when it works out nicely. And I get 10. Divide by -10, divide by -10. And my answer is y equals -1. So my final answer is, oh, I haven't figured out x yet. Y equals -1. That was a lot of work just to figure out what y was. So if I know y equals -1, go back to one of your original problems. I'm going to do x plus 2. Instead of writing y, I'm going to write -1 equals 6. X minus 2 equals 6. Add 2 to both sides. X equals 8. So there's my answer. That's my x, that's my y. Always write my x first, my y second. Bam. Okay. This is nicely already in this form. Let's just plug this, substitute it in here. -6x plus 3 times 2x minus 4 equals -12. -6x distribute plus 6x minus 12 equals -12. Negative 6x plus 6x is 0x. I get negative 12 equals negative 12. We know that when we have an answer and it comes out true, but there's no way to solve for x and y, we know that's going to end up being the same line. That's the same line. There are infinitely many solutions. Infinitely many solutions. So in other words, these are the same line. Okay, now watch, I don't know if you noticed, but if I divide everything in this equation by 3, I would get negative 2x plus y equals negative 4. And then if I brought the negative 2x over, I would actually have that same equation. So these two are the same equation. Infinitely many solutions. Okay, last one. 2x minus y equals 8, y equals 2x minus 3. This is the one that I can plug in. I've got it into y equals, so I'm going to take what y equals, plug it into y, into the other equation. Minus, now notice if there's a minus in front of the y, always put the parentheses, because if you don't, you will mess your minuses up and you'll mess your signs up. So let's distribute the negative. Whatever's parked outside the parentheses, you have to distribute. 2x minus 2x. A negative times a negative is a positive. Okay, we get another problem here. We get 3 equals 8. Guess what? 3 does not equal 8. 3 does not equal 8. There is no solution. No solution. Why? Because these lines are parallel. Let's just check it. If we get this into y equals mx plus b, we know the slope in this one, it's already into y equals mx plus b. Slope is 2. If I got that into y equals mx plus b, I would just bring the 2x over and I get negative y equals negative 2x plus 8. Divide by a negative 1, which flips all the signs. Notice the slope here is also 2. When you have equal slopes, they are parallel. I will see you tomorrow. Make sure you take good notes. Bye-bye. Come get your lunch.